Hello students, next we'll move on with the different scheduling algorithms, that is CPU scheduling algorithms. To begin with, first one we have is FCFS, or you can also call it as first come first serve. So what is happening in this FCFS is, so whatever process that has come into your system will be stored in your ready queue. So whichever process has come in first, that will be the first process to which CPU will be given and allowed to execute. Okay, so this kind of problems will be asked to you. You have to solve it using what is called as your Gantt chart. Okay, so let's start with the problem. So the problem given here is, consider the following set of processes that arrive at time 0 millisecond. So time 0 millisecond, arrival time means when they have come into the system. So that time they have given us 0 millisecond. So all the processes have come in together, okay, at time 0 millisecond, with the length of the CPU burst given in millisecond. So this burst time whatever you can see, that is called as the CPU burst. That is nothing but how much time the particular process takes to complete. So according to this, P1 takes 24 milliseconds to complete, P2 takes 3 milliseconds to complete, and P3 takes 3 milliseconds to complete. Okay, now we have to calculate average waiting time and average turnaround time. So to find both of this, we have to draw what is called as Gantt chart. Before that, you have to remember this formula, that is turnaround time. TAT is nothing but turnaround time. So the formula for turnaround time is burst time plus waiting time. Burst time we will get it in the question, and waiting time we are going to find using this Gantt chart. So we'll draw this Gantt chart and I will tell you how we can solve this problem. Okay. So this Gantt chart always begins with time 0. Okay, that is 0th millisecond. So we said all the processes have come in together at 0 millisecond. So our algorithm is first come first serve. So whichever has come in first, that will be the first process to whom CPU will be given. Now according to this, all the process has come in together. So in this kind of situation, what you have to do here is, you have to see the question according to the order how it is written here. According to that, we are going to give the CPU to the process. So according to this, P1 is first, so we will write here P1. At 0 millisecond, P1 will be given the CPU. So whichever process will be given the CPU, that will be written inside the Gantt chart. So P1 takes how many milliseconds to complete? It takes 24 milliseconds to complete. So from 0, you have to write up to 24. So what is the meaning of this? P1 has CPU has been given to P1 at 0 millisecond till 24th millisecond. At 24 millisecond, P1 has completed. Now the CPU should be given to the next process, which is that next process in the order, that is P2. Okay, P2 takes how many milliseconds to complete? 3 milliseconds. So for this 24, you add 3 milliseconds, then it will be 27. So P2 will complete its task at 27 milliseconds. Okay, I hope you are getting this. So P2 got the CPU at 24 millisecond. It completed its task at 27 millisecond. Next, which is the next process, P3. P3 takes how many milliseconds to complete? Again 3 milliseconds. So for this 27, you add 3, then it will go up to 30 milliseconds. So all these are not required. So at 30 millisecond, P3 will complete its task. Okay, so this is called as your Gantt chart. So for first come first serve, we are speaking about non-preemptive. Non-preemptive. So what do you mean by non-preemptive? Once the process is given to a CPU, then forcefully you cannot take the process away from the CPU. Now you have to calculate the waiting time. Okay. So waiting time for each of the process P1, P2, P3. So we will see what is the waiting time for each of the process. So waiting time is nothing but how much time the process is been waiting in the ready queue. for its turn to get the CPU. So you can see P1 has come in at what time? So we said all the process has come in at 0 millisecond. So P1 has come in at 0 millisecond, that is arrived at 0 millisecond, and at what time it got the CPU? 0 millisecond. So P1 0 minus 0, that is waiting time for P1 is 0 millisecond. I hope you're getting. P1 arrived at 0 millisecond and it got the CPU at 0 millisecond. So 0 minus 0, it is 0 millisecond. Now calculate the waiting time for P2. P2 came in at what time? 0 millisecond. But at what time it got the CPU? At 24 milliseconds. So how you have to calculate the waiting time? 24 minus 0, that is 24 millisecond. So P2 was waiting in the ready queue for 24 millisecond. Similarly for P3. P3 came in at 0 millisecond, but at what time it got the CPU? 27 milliseconds. So 27 minus 0, that is 27 millisecond. So this is how you are going to calculate the waiting time. Now you have to find the average waiting time. How we are going to calculate the average waiting time? 0 plus 24 plus 27 divided by 3. So how much you're going to get? 3 is nothing but how many number of processes. So how much you will get? 11, 51 by 3. 51 by 3 is around 17 millisecond. Okay, so this is your average waiting time. So we are done with the first part of the question. Now you have to calculate the turnaround time. So turnaround time. So what is the formula for the turnaround time? Turnaround time is nothing but burst time plus waiting time. So for each of the process you have to calculate. So turnaround time for P1, P2, P3. P1. What is the burst time for P1? Burst time for P1 is given in the question. It takes 24 milliseconds. And what is the waiting time for P1? That is 0. So it is 24. Next for P2. P2 burst time is 3 milliseconds and waiting time is 24. So 3 plus 24. How much you're getting? 27. Next for P3, waiting time is 27 millisecond. Burst time is 3 millisecond and waiting time is 27 milliseconds. So how much you're getting? 30. Okay. So now you have to calculate average turnaround time. So how we are going to calculate average turnaround time? 24 plus 27 plus 30 divided by 3. 3 is nothing but how many number of process. So how much will be getting? 1, 5, 6, 7, 8. 8, right? So so 27 millisecond. So this is therefore the average turnaround time is 27 millisecond and average waiting time is 17 milliseconds. So this is how you have to solve it. I hope you are clear with this. We'll do some more problems. Okay, thank you.